Hey everyone, this is lesson 711 to 715 on quadrilaterals, part 3. In the first two parts of this lesson, we've gone over quadrilaterals, their definitions, their relationships, what their shapes look like. Definitely, this is something you should review. You are expected to know the names of all these shapes, and their definitions and what those definitions imply. So don't be surprised if that kind of pops up on a test. Something very focused on you knowing vocabulary. Do you know the shapes and key things about them, right? That a right trapezoid has two right angles, or that a rhombus has four congruent sides. So definitely make sure you're aware of those details. Maybe make some flashcards, do something to help you kind of memorize those. If it helps you, I would also include pictures of what those shapes look like, and maybe even other shapes that might be under the umbrella of that shape. So if you understand what a parallelogram is, then hopefully you understand that a rectangle, rhombus, and square are also considered parallelograms, right? And so keep that in mind, or that a kite does not have any parallel lines. It's the only shape that does not, besides the general shape of quadrilateral. So make sure you understand all these little details, definitions, pictures, how to draw them, and maybe even how to put markings in the right place so that you could tell these shapes apart. All right. So when we review this, I think when we go over review, I'm going to try to quiz you on this to see if you could tell these shapes apart. Now, in addition to these quadrilaterals, there's a few terms and relationships I wanted to go over. Even though this notes is titled quadrilaterals, technically we're not really talking about quadrilaterals specifically in this lesson, but we do see some of these terms and relationships within our quadrilaterals. So specifically this one, perpendicular bisector, something you need to be familiar with. I'll just kind of give you a visual. First visual would be maybe something like this. I'm going to draw on these extra lines. If you notice, that is a picture of a kite, right? So this is a picture of our kite. But what I'm focused on is really this relationship of the diagonals. All right, so we would say that the diagonals are the long diagonal is a perpendicular bisector of the short one. And so let's look at a more formal definition. A perpendicular bisector is a line that is perpendicular to a line segment. All right, so in this case I have line L, so there's this L here to describe the name of the line, and this line is perpendicular to a segment AB. So segment has two endpoints, A to B. So it could actually put perpendicular, means there's a right angle there. And it passes through, it says it passes through the midpoint of the segment. So between A and B, right in the middle of A and B is point M, which is the midpoint. So we have a midpoint. And so since this line goes right through that point, that tells us a couple things. And the first is, just by knowing it's a perpendicular bisector, then that M has to be the midpoint, that's for sure. And since that's the case, then AM is congruent to MB. So if I look at the picture, AM and MB have to be congruent. So that means technically I could put markings here to say these two segments are the same. Now, the reason why do we need to know this? Well, notice I've added markings. Tick marks, and even a 90-degree angle. And I only was able to add that because I knew this was a perpendicular bisector. So a typical problem that you might get will not give you the markings, and so you would not know if that's a 90-degree angle. You would not know if these segments were congruent. But as soon as they tell you you have a perpendicular bisector, they've given you a couple of pieces of information. And so that's crucial in making the next step. So just by this telling us that, that's already telling us, almost confirming that we have something that looks like a kite. So if we didn't know this, then we could just say it looks like a kite, but maybe it's not. Maybe this is not 90 degrees. Maybe it's 89 degrees. So in this case, we do know it's 90. All right. So that's one thing you need to know. Basically just terminology and kind of that definition of what perpendicular bisector is. The second is a theorem called triangle midsegment theorem. And I'll stop it there. All right, so we have this triangle, and it's kind of even similar, just to kind of flashback to when we first started these notes. We had a triangle, and then we reflected it, and we had a parallelogram, right, just to kind of make connections back to the quadrilateral. Or even if you look at the bottom half of this, it looks like a trapezoid, right? So that's kind of the connections we're making with quadrilaterals here. In this case, if we are given a triangle like this, a triangle ABC, and if D in this diagram happens to be the midpoint, again we're using the word midpoint of AC, which means D is right in the middle, and E is the midpoint of BC, so E is in the middle of BC. Then what we can name this segment DE. If we actually connect those two dots, we can name them as the midsegment of this triangle. So DE is the midsegment, which is the segment that's in the middle of the shape. All right, so why is that a key thing to know? Well, because this is in the middle, again, we do know that these markings are going to be, tells us these portions are going to be congruent. But what we don't know is what's the relationship between the two bases of these triangles. So there's a small triangle at the top, and then there's the large triangle, the whole picture, right, in these nested triangles. The question is, how are these related? These are not the same length, right? These are not the same length. But the length of AB, which is the bottom, right, length of AB, is double the length of DE. Well, so if I know what DE is, then that means I know what AB is. So AB is going to be equal to twice the length of DE. So, all right, so let's see if you paying attention. If I say DE is, let's say 10, what does AB equal to? All right, let's see if you got that right. So this is 10, this is 20. All right, what if I say AB is 100, what is DE equal to? Can you go backwards? All right, it's smaller, so what is this equal to? All right, let's see if we got that correct. So this would be, if this is 100, then this would be 50. All right, so let's look at an example I have drawn out for us. So if you still were confused, this would be an example of, it's pretty much the same picture as above. I've just added in the numbers like I just finished doing with you. If you're given directions to solve for x, your first task is really to check to see even if you have a midsegment. So we have actually seen this problem before in an earlier chapter, but we solved it a different way. And I'm going to show you. I'm going to actually show you that method right after this one. But since this is the midsegment, and I know this is a mixed segment because we just finished talking about it, these segments are the same, right? So that must be in the middle. And these two are the same, so this must be in the middle. So that has to be a midsegment. And if the midsegment is 15, then I could say x is equal to 30, right? Because 2 times 15 gives you 30, right? This is the type of problem where a lot of times students don't show their work. I would strongly recommend you still show your work. It's a simple work, 2 times the number, right? So if you just put 30, I don't know if you were guessing. I don't know how you came up with that number. But just by putting x equals to 2 times 15 tells me you understand the relationship. So don't underestimate one step as simple as this. All right. And so the problem we've seen before that looks very similar to this is it's basically the same picture. We have a line here where I gave you the measurement and I'm asking to figure out what x is. Most of you, and this typically happens when I go over these type of problems, is if I give students this problem now, most students will say, oh, wow, this is 12, so this must be 24. Is that true? Well, the issue is this is not a midsegment. And why does that matter? And how do I know it's not a midsegment? Well, I see this is 3 and this is 4. These are not even equal, right? So in the above example, these two segments were equal to each other. These are not. So this point is not in the middle. It's on the line. It's somewhere in between A and C, but it's not in the middle. So that way, that's how I know this is not in no way a midsegment. So we'd have to use proportions to solve this. And so the way we do that, we've done that before, is something like this, where I know 12 and x are corresponding sides. So I'm going to create a ratio of x over 12. I put x on top just because it's I like putting my x's on top. If you put 12 over x, that would work as well. What matters is the second fraction and making sure the numbers are corresponding. So 12 comes from the small triangle, and I need a side, another side from that small triangle, which is 3. So that's why I have 12 and 3, both on the bottom here. And since I used x for the bottom of the big triangle, I need to know what the length is of this side. So it's not 4, but it's 4 and 3 together, which means I'm going to add 4 and 3 to give me 7, which is why I have x and 7. So x and 7. All right, so that's how you would set up a proportion, and then we would solve this. So what does this give us? If I solve this proportion, what does x equal to? I'm going to let you see if you could tell me. All right, let's see if you got this correct. So if you cross multiply, you should have ended up with x equals to 28. So that's, if you need me to show work on that one, that would have been 3 times x equals to 12 times 7. Right? And if you divide both sides by 3, right, we'll end up with 28. So I could show a couple of extra steps, but I know 12 divided by 3 is 4. So this is really 4 times 7, which is 28. So I didn't even want to multiply 12 times 7 because I was afraid I might make a mistake. All right. So that is, that's pretty much it. So I want to go back up to the mid-segments. So this is really what we were trying to learn today. In addition to perpendicular bisector, I wanted you to know the triangle mid-segment theorem. All right, that's it for this lesson. Let me know if you have any questions.